Okay, hi everyone. So the Babylonian sequence is a famous sequence, so let's learn about it. Well, we already proved that square root of 2 is not a rational number, but actually we can approximate it using just rational numbers, and in particular a sequence of rational numbers that will get closer and closer and closer. So first of all, before I solve this problem, let's just look at what that looks like. What we're going to do basically is create the next number, the next number in our sequence by averaging the old number and 2 divided by the old number. Okay, so in a formula, this says that xn plus 1 should be equal to, well, the average, so I'm going to take 1/2 of the sum. Okay, so this is a recursive formula. Recursive. And so like if I let x0 be 3, then x1 will be 1/2 of 3 plus 2/3, which is 11/6 if you work it out, I believe. Yeah. And then x2 should be 1/2 of x1 plus 2 over x1, which is, I guess, 1/2 of 11/6 plus 2 over 11/6. Are you okay with the fractions I just did there? Take a moment to think about it. And blah, 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 blah. You have to work this out, and it turns out that is equal to 193 over 132, which, notice that if I started with a rational number, like 3, which is 3 over 1, then I get 11/6, and I get this number, which is also a rational number. It turns out that x3, if you plug this in, 1/2 of 193 over 132 plus 2 divided by 193 over 132, and you work it out, what you get is 72097 divided by 50952, which is again a rational number. And if you actually divide this into decimal form, it looks like this. Anyway, I'll stop. But you notice that it's looking like it's very close to square root of 2, and we just did the third element of the sequence. Later in this course, we will prove that the Babylonian sequence, the x sub n's generated by this rule recursively, converges to the number square root of 2. It gets as close to square root of 2 as you like, provided you go far enough out. So if this is close enough, you only had to go to x sub 3, and that was very close to square root of 2. Okay. But, so that is how this actually works. But that is not what the problem asks you to do. So let me move this out of the way. What the problem asks is, please derive this formula using linear approximation for a map. In other words, to go back to calculus and think about how does calculus actually give us the formula. So derive this formula, what formula? In words, here it is. It's this formula in words. But in formulas, it is 1/2 of xn plus 2 over xn. Okay? That is the average. Okay, so linear approximation. Super, super important. In particular, Newton's method, first of all, for those of you who aren't familiar with this notation for the derivative, you could just write that f at x plus v is basically f of x plus the derivative of f at x times v. This purple formula works for when the function is just a real number to a real number, like this is a real number to a new real number. Okay. So what does this say? Well, so Newton's method is sometimes what this is called, but it basically says, let's consider a map F that sends x to x squared minus 2. We want to find zeros or roots. In other words, solutions. Okay, so what should we do? Well, we should use this. We want, so we'll guess x0 equals 3, okay? That's what we did. We could start with any number, but we'll just choose 3. Or any initial guess. And then we will solve for v using star. Now what's star? Star is this formula. I'll put this formula. Star. The linear approximation formula. Okay, so what do? So if we take this formula, well, let's just write it out. X plus v is basically f of x plus f prime of x times v. We want to solve for v to figure out how we should update. We're going to start from x0 and we want to update, start and then update x1 equals x0 plus v. Okay, and this is going to basically produce this formula. So we have to figure out what v is, and when we add v to x0, we'll get this, basically. Okay. So let's see what it is. F of x. Let's now call, let's call this f of xn plus v is f of xn plus f prime of xn times v. And now solve for v. Well, we want this left-hand side to be 0. So 0 equals, now what's f at xn? Well, that's xn squared minus 2. Do you see what I did? Plus the derivative of f, well that's, I guess, 2x is the derivative. So I'll even write that, f prime of x equals 2x. So I'll just put a 2xn times v. Okay, and that's it. Now we just solve for v. And we're gonna get this formula right here, eventually. Okay, so let's solve for v. Let's bring these over to the other side. So I get 2 minus xn squared equals 2xn v. I divide both sides by 2xn. I'll get 2 minus xn squared over 2xn equals v. Okay, and I guess I can divide this through. 2 divided by 2xn is 1 over xn. Xn squared divided by 2xn is okay. That looks pretty good. So what I should do is I should compute xn plus 1 should be xn plus my update. So that means we get xn plus, now what's v? 1 over xn minus xn over 2. Okay, but look, I mean, I've got 1 xn minus a half xn. 1 xn minus a half xn is just a half xn plus 1 over xn. Okay, so then let's look at my formula now. Xn plus 1 should be xn over 2 plus 1 over xn. And that doesn't quite look like this formula up here. Do you see what I should do? I'm going to factor out a 1/2. That leaves an xn remaining. and a 2 over xn there. This step right here, take some time to look at this. Make sure you understand what I did. I found this confusing. But yeah, I just factored out 1/2. I mean, you could just multiply through and see that this f actually does work, and that's maybe easier. Anyway, that is it. Now we're done. Done. So it turned out calculus was useful. Although square root of 2 was not a rational number, using calculus and the linear approximation formula, we can compute a recursive sequence where each number gets better and better and better. We start off with 3. 3 is not very close to the square root of 2. What does equal mean there? Anyway, but 3 is not a very good guess. But 11/6 is a little closer to the square root of 2. 193 over 132 is even closer still to the square root of 2. And this one is already very, very close with just x to the third. If we wanted even closer, we could go out to maybe x to the 10, or x10. Yeah. Sometimes you say x sub 10 if you're reading this, or just x10, but it's a subscript. Subscript, or sometimes called an index. Okay. Take a blank sheet of paper. See if you can do this problem on your own without looking. Remember, I actually gave you this formula as part of it. And I also get, everything in black ink will be given to you on a quiz, for example. And then you have to do the rest yourself. You have to work through this story in a way that you understand it and end up with the correct Babylonian sequence to approximate the square root of 2. Quiz yourself. Okay. And if you like puzzles that you don't know the answer to, can this work for the square root of 3? What about the square root of 4? Can you approximate these numbers using this same method? What would you have to change